Hello friends, I am Dr. Prof.Chishty and I am teaching physics to the BSc second year students. My topic is crystal structure in the solid state physics. Now today we are going to learn about the symmetry operations in a lattice point or applied to a lattice point. We know very well about the lattice points that the lattice consists of the systematic arrangement of the points, and these points are equidistant. They are arranged in a very systematic manner. So when we apply the symmetry operation, for example translational operation, rotational operation, or the inversion operation or the reflection operation, so that the crystal should remain invariant, such operations are called as the symmetry operation. So we can define the symmetry operation is a operation which transforms the crystal to itself. The crystal should remain invariant under the symmetry operations. So how many types of symmetry operations are there? Here in 2 dimension and 3 dimension we can perform translational operation, reflection operations, rotational operations and inversion operations. So we will study these symmetry operations one by one. So first we will study about the translational operation. Means we have to translate a lattice point so that the point should remain invariant. For example, in this lattice I will consider a point O here, and this point is R. So I will translate this point R about O to some unit vector. Suppose here it is R dash. Okay. So for that purpose I will write here the vector R plus T, translation vector, should be equal to vector R dash, where what is the value of this one? Here it is, suppose the distance A, and here it is the distance minus B. So translation vector can be written as n1A plus n2B, where A and B are the fundamental vectors. So I will translate this vector, that is T is equal to n1A, means I have to go to this point, means I will travel 1A distance, and then I will travel downward distance, means minus 1B distance. So we can find the value of T, that is the translation vector. R should plus 1A minus 1B equal to R dash vector. Means we have translated this point about this point so that the atmosphere surrounding to it, the lattice point surrounding to it, should remain invariant by using the translation operation. So we can translate in 2 dimension, we can translate any lattice point about a given point O or about any given point. So this is the first operation. Now let us see about the reflection operation. So to study about the reflection operation, I will take here one lattice, that is a square lattice, a square that is having the 4 points A, B, C and D. And I will find here the transverse axis, and I will see that whether there is the reflection of the point A and B is there or not. So I can say that the point A is reflected to point D, means this distance is equal to this distance, means point A is similar to point D. Similarly, point B is reflected as point C. It means that it is having the symmetry operation, it is having the reflection operation in 2 dimension. If I take the example of the circle also, then we can take the symmetry along this axis, as well as we can take the symmetry along this axis or any given axis which is passing through the center of the circle. Means here also we can take the symmetry about the horizontal axis. So a reflection operation is an operation in which the lattice points can be seen on the another side of the reflecting axis. So this is all about the reflection operation. Now the rotational operation. Again I will take for the rotational operation, if I am having the four lattice points A, B, C and D, here is A, here is B, C and D. The angle between these points, lattice points, is suppose 90 degree. Now if I will rotate this lattice in the anti-clockwise direction or in the clockwise direction, then after rotation this point A gets shifted to B, means here there will be A, B gets shifted to C, here is B, and the C gets shifted to D and D gets shifted to A. So we can say that here there is one rotation, and if I rotate it again, then the A will be get shifted to B, B will be get shifted to C and C. So in this way there are four types of rotations are possible. So we say that n theta is equal to 360 degrees. 90, 90, 90 and 90 means 4 times rotation. Means in each type we are having the value of angle as 60 degree. So we can say that there are 360 rotations. So n, the value of n is 360 upon 60. So we get the value of n as 4. Means the number of rotations 1, 2, 3 and 4. So in two-dimensional lattice, the operation n equal to 5 is not allowed. N equal to 7 is also not allowed operations. So in general we can say that n theta is equal to 360 degree. Now we can also say, if I take the example of a circle, suppose here, then if I take the example of this circle and I take the symmetry axis, means 1, 2, 3, 4, 5, 6, 7. How many angles are there? 1, 2, 3, 4, 5, 6, 7 and 8 angles are there. So total angle is 360. 360 upon 8 means I will get here, each angle is of 360 upon 8, 360. So if I take the 8 parts, that is 1, 2, 3, 4, 5, 6, 7, 8, then 360 by 8 will give you the angle 45. So here in this case the angle n theta, that is the n is into 45, is equal to 360. So value of n will be equal to 360 upon 45. So I will cancel it as 9 5s are 45, 9 4s are, means here there are 8 symmetry operations are possible. 8 symmetry operations are possible, and we can avoid here 5 and 7. 5-fold and 7-folds will not be there. So this is all about the rotational symmetry. Now if I take the example of the inversion symmetry, what is the inversion symmetry? So inversion symmetry will be there in the 3-dimensional lattice. So I will consider here a lattice, 3-dimensional lattice, square lattice, a cube. Now if suppose from this point I am inverting this through a distance r, through an operation r, means I am inverting this cube through a distance by r, by operation r. So I have to invert this point, I have to rotate or I have to invert this point through a distance minus r. So this type of symmetry is known as the inversion. Inversion means the points will be replaced by the another point after rotation. When inversion operation is performed on a lattice point, then that point get inverted. Okay, so we can see that in symmetry operations we are having the translation operation, reflection operations, rotation operations, and inversion operations, which we can easily study. Thank you.